should I call this? Someone should give me no. Let me say, okay, so where to start? Is anyone trying to join or someone has a question? Where to start? In building a simple show. Where to start? Yes, citizen, please, you have a question.
No, go on. This is where I'm testing on hearing
I should go
where
on.
to
Okay.
start.
Yes, so where to start in the implementation of our own simple show? Where to start? Good. So this is how I've taken time to write down and break it to simpler for you to understand. But um, please, this section is recorded. If you don't understand anything, because you need to before you start where to start, you need to understand some of these things, especially if you're new to what the simple shell. So I think I try to get a YouTube channel for it. Yes, I'll share the YouTube link in the I'll share the YouTube link in the how do we say in the group. Yes, so that you can revisit it and be able to come back to it. Let me leave it in the chat. See. So this is what I want you to do. Everything is like you asking yourself, if you were sure, where would you start from? If you were sure, where would you start? Okay. So I'm always like think like the shell. Okay. Even I'm like think like the shell. I'm also like you are the computer operator. Okay, so you are the computer operator. You have to think like the computer operator. If someone comes to you, okay, how does it start? Someone walks to you, what happens? How do you take their command? How do you execute it for them? How do you give them their request? Think like shell. What would you have done? So the first thing you would want to consider as shell, okay, when in order the first thing you want to consider first is the user input. Let's start with this. Is the user input. Okay, because basically, whenever everyone opens a terminal emulator, the first thing you want to do is what? As shell, the first thing you want to do is what? Is to check their input. Are they typing? What are they typing? You have to keep track of it, and you'll be able to what? Get hold of it. So before I missed a very important step. Before that, let me move on to something. The user input, okay, I missed a very important step. So basically, the user input is like you taking what input from the user as the computer operator. You taking input from the user, and then we know and you knowing the right function to use, the allowed function to use, the best function to use, and ALX doesn't allow printf. Sorry. Normally on the regular we use scanf to take what input from the user, right? The family of the scanners, you have SS scanf and what have you. We use them, but ALS says no, and it's very important why they are saying no, because you'll be dealing with file streams and everything. You need to use functions like to take inputs. You need to use functions like get line, read. You have to use system calls, okay, and they have their reasons. So before that, let me explain something to you too. It's also one of the things you need to know so that you know how to start your program and where to start. We have something called processes. Okay, before you start, we have something called processes. Who knows what a process is? Because of time, I will not be waiting around. So it's an instance of a running program when the user enters ls, okay, and you're executing the program. At that moment, the program is running. It is an instance of a running program, an executed program, an instance. Okay, so at that moment, it creates a process, and that process is what whenever you take inputs from the user, okay, and then you try to work on it, there is something called process. It keeps track. It's like, let's say when I do this, when you enter ls, LS is a program. Oh, LS is a program. I ran LS. Before LS was able to execute, there was a process. So it is an instance of what? A running program. First of all, I've explained to you how LS is a program, right? So a process is an instance of what? A running program. So let me go into details. It's very, very essential, please. If you don't understand the concept of processes in in running programs, you might write your shell which would not do exactly what you want to do. Because how should I even explain it? Because every process has a unique ID, okay? So processes have unique IDs. So process IDs. That way you're able to keep track of the programs. Did it run well? Did it execute? Did it fail? Did it give the user the correct output? You want to track that. And what you have to use is for the process ID. In the Windows operating system, okay, we have the task bar. Yes, most of us are familiar with the task bar. This is what will be simpler for me to explain a process. Okay, so we have the task bar, and this is what happens. You see, as it's indicated here, it's processes. This is what is happening. All these what are programs. They are running programs. They are processes that can be killed. That can be stopped. You can do everything you want as long as you have what the process ID. Okay, so it says type a name, publisher, or PID to search. So the PID is the process ID. When you enter the process ID here, it will search for the program that is what in charge of what, or the process ID that is what keeping track of what that particular program. We are not much into the Windows section, so I'll use this one to explain it. When you click on options, you can end the task. You can do everything, anything you want with this process. Okay, so let me use the concepts or how it is relevant in shell, and let me use it on the Ubuntu operating system. So let's say I want a running instance of a program or a process. That way I can be able to, not a one that has finished. So let me get it. I've forgotten quite a command. So with this one, kindly allow me to use my vagrant. So this vagrant for I have here is what? Is a bash. It's a bash script. It contains commands for the computer to follow. So when I open it, this is what it does. It follows the command vagrant app, and then it runs vagrant SSH. So it's basically a list of this file is basically a set of commands. I don't know why it's not running now, but it's supposed to be running. And this is supposed to run now. Why? Because I moved vagrant to a different path. Let me just go there. Guys, please exercise patience. Let me try and get my vagrant app. So for one thing I know is in the D. Okay. So vagrant app. Okay. It seems this one has worked. So you let's not worry about that. So but I don't know why it took so slow. Guys, can you hear me? So guys, can you hear me? Am I still audible?
We are hearing you.
Yes, good. So this is vagrant. Okay. I want to use this to explain the concept of what processes. It makes it easy because you can see here it has processes. It makes it easy for me to implement the use of process. So let's say in your simple shell, okay, you want to handle process like let's say in situations, one of the allowed system calls is what? A kill. What this kill does is that it is able to terminate processes. So let me explain. So let's say let me switch to the root user. Let me clear the screen for you to be able to see. Let me switch to the root user sudo su. So this is the root. Okay. So I'm going to try something here for you to be able to see and learn from. So Vagrant is a user, as you can see, the one in green, Vagrant at Ubuntu here is a user. So as long as you've logged into that user, there is a running instance of what? Of that process. There's a running instance. So this is what I'm going to do. I'm going to try to you delete that user. Though it is running, I'm going to try to delete it and let's see what happens. It says that the user is currently used by what process what 2034. Okay, so it is trying to tell you that it is a running process. It's an instance of a running program. So you can't delete it because it's being used. It's a running process. So this is what we are going to do. But I want to terminate the process. So if you want to terminate it, what I want to do is I want to get access to the ID which they provided for me. So this is what a process ID. And when I run kill 20314, I don't think, yes, I can't kill it because it needs to what, survive for for this show to be able to, for this terminal to be able to still work. But if I want to still kill it, if I want to still get rid of this process, I can still have access, so as long as I have what, the process ID. So let me try that. So let's try this new process, kill 20391, right? 20391. And when you do this, when you code this process, this is what's going to happen. They're going to log you out of the vagrant. It's going to close because you are killing the process. That is what that the process ID. That is what is running what, the vagrant. So you are trying to kill the process. You see, so that's what happens, guys. If you saw that, it just closes the ID. So all of these programs to where is my virtual? All of these programs like the LS and everything, all of them have an ID. That's what helps you to be able to keep track of them, not to confuse and make it plenty for you. So you need to what? Take note of that. There is this PPI. Is it PPID or PID? PPID. Yes. So let me get back to it. So in order, that was what I wanted to touch for us to move on. All of these things have process. You have the parent process and the third process. We'll go more into it in our next section, how we are going to make use of it in our shell. So first of all, you want to handle user input. What is the user typing? What are the user send? So you want to make use of functions that are going to what, are going to take the user input. And two, the second thing you want to know is, or you want to do is, you can use this as basically a paradigm to be able to follow through. The second thing you want to do is you want to pass the input. Okay, so this input that you took from here, you are going to pass it. What does it mean? When a user enters LS, this is very tricky. It gets most of us confused. When a user enters LS, okay, we know that ls is a command. We execute it. But what if the user enters ls dash l? How should if you are sure, how would you interpret, how would you understand the difference between this and this? How would you handle it? You first need to know that this is what is an argument, right? Or is an option. And this is what the command itself. So that is basically the meaning of what passing input, being able to differentiate between the command and the options provided to it. Because the dash L is not a program, it is what, a command. It's an argument that is passed to what, the program itself. And this is a bit of trouble. I think this one we can use string token to tokenize them. I'll go through all of this to tokenize them to be able to know, for the shell to be able to differentiate between what, the program and what its options. Because of time, let's try and move on. So the third thing you want to consider is what? You want to consider handling built-in functions. So you want your shell to be able to handle inbuilt functions. Okay. What are inbuilt functions? Inbuilt functions are basically commands, okay, that a shell handles internally. That's why I was saying something like, I can't use this command cd. Okay, I can't say cd is what is part of the operating system. It's an executable file in the operating system because cd. Let's try and find cd in the operating system. Let's go bin. Let's list it and see if we find cd. So CD should be somewhere here, right? Yes, as you can see, we don't have CD as a command on its own. I don't know if you guys can see. Because CD is what? Is not a command. in the operating system. It's an inbuilt what function with a shell. Shell handles it internally. So whenever you enter CD, it doesn't have to go through any procedure of finding where CD is and executing it. You have to handle that what internally. So I wanted you to take note of that. Commands like CD, exit, when the user enters exit, you want to handle it, right? What does it do? You want to handle all of these things. I can't use my virtual machine to illustrate that, but let's see. Did I close it? Yes. If you have something like exit, will it even work here? Yes. So yes. So all of these things, some of these things have inbuilt what commands. So you want to handle that too in your course, okay? You want to inbuilt functions. Like let's say example, if the user enters commands like exit, cd, um, which other command can we even say? Quit? Is it quit? Quit. I think quit does the same thing. At least from Python, I know that quit will quit the terminal or something. So these are some of the inbuilt functions. Please research on them. In our next section, we'll go much into details how we are going to implement all of these things, the right functions to use and encode. But for now, use this as a guide to go to search wherever you want to search. It be ChatGPT. Okay, so let me illustrate that how you are going to do that so that you're able to learn them yourself in our next meeting, because in the next meeting I will not get time to go through some of these things. So let's say the topic I've given here. Okay, handle inbuilt functions. You want to ask ChatGPT, please don't ask it to write codes for you because you know why. So let's say if you have something like let's say handle um we are handling what inbuilt functions. So you want to ask ChatGPT like how do I handle you want to ask ChatGPT things like how do I handle inbuilt functions in the building of my own show. I'm giving you a guide on how you are going to learn the steps I'm giving you, my own show. So you want to be more precise and add more details. ALS held alive on how to use ChatGPT. So yes, so it will basically give you the answer like when building your own simple show, you want to incorporate the ability to execute built-in functions. You see, it gives you examples like CD, exit, how you're going to handle them. It gives you some codes to test how it all works. So don't copy codes from it though. Just let it. You add more details, add restrictions. I will send the link to how to use ChatGPT in the group too. So for now, please go and make use of these things I'm mentioning. When you're able to understand it, you'll be able to know how to implement them in your in your codes. So we have something like handling inbuilt functions and also managing processes, which I just talked about. How you are going to manage processes, very critical. You want to keep track of every program instance. So managing processes. I just explained that one. Child process and parent process. Please read into it. Child and parent process. Because of time, let me touch a little bit on it. So when you use system calls like fork, okay, when you use system calls like fork, it duplicates what the process, and the duplicates you get become the child process of the parent process. So let's say when you use fork system call in your codes, what it does is that it creates a duplicate of another instance of of the running program, and what you get, you have the child and the parent process. It's critical. Let me explain it to you guys with the Ubuntu. So we wrote. So this is what if you want to understand more into it. Okay, ALS give us a link concept called what was the name? Can anyone remind me what is the concept ALS gave us to explain processes? But it's there. It's on your intranet. Okay. My partner and I actually used that one. The first concept they gave you, right? Go into it. You're going to see. I can't share my intranet with you for copyright issues. So what you're going to do is you're going to want to go through For now, please go through them. Okay, take time. You have a lot of days. Read through everything. What happens is that when you're able to perform the exercises Julian is asking us or ALS is asking us to do, when you're able to complete that one, you realize that you have a sample code you are going to be working with without having to what? If you're able to write everything, I wrote mine here. I think in a file called Simple Show. Let me get that. Is it CPS, LS? Hey, Atobrame Yekowai. So LS, then you want to go to CD. Is it my projects? No, not here. I think I wrote it somewhere. I've just forgotten LS CD project. I know, right? My parts are plenty. They're a lot. So it makes it very difficult. CD lessons. Yes, I think it's here. Yes, so CD simple, sure. This was a result of no. Let me get out of here. Sorry about this. This was a result of what I want to do with it. So we have our trial code. I have my trial codes here. This was what I was able to come up with from the ALS concept. And you realize that by the time you are done with this, okay, listen to me. By the time you are done with all of this, some of this, I think it's PPID. It teaches you PPID arguments. By the time you're able to down with it, let me run this for you to see. No, this is an executable. You realize that it prints what the process because I have the program there. So go through it, do the exercises. If you don't understand anything, you can ask me. If you don't understand anything, you can equally ask ChatGPT, and it makes it easier for you. Okay, so you get introduced to system calls like fork. If you're already introduced to fork, please take note of it. The next section will you see how we are going to be using them in our codes. So so it's very essential to know how to manage your processes because you want to start the process, you want to monitor the process, you want to terminate your process if possible. And the last one is what handling, how you're going to handle input and output redirections. I think I heard a blink. Was it a hands up or someone trying to join? Yes. So the last one you want to do is what? Is to handle what? Input and output redirection. That is the last thing you want to do in your simple shell. Not the last, but the fifth, I'll say. You want to know that, let's say, if the shell receives commands like echo, as I was explaining earlier, if it receives the greater sign, the greater than sign, the less than sign, what should it do with it? You want to handle these things. So this is a touch of the basics, and let me get back to it. As I said, the section is recorded, so you can get back anytime and then go through this, how to handle user inputs, how to pass the input, how to handle inbuilt functions, how to manage processes, handle input and output redirections. So you want to check that. So before I call this meeting off, let me add some things to it. Check this out, though it's in the ALS resources. Okay. So you want to check this out. System calls that you are going to be using. You are going to be using fork, okay? You are going to be using exec. The exec is a family of functions, but mostly we'll use the exec v. It's a function. It's I don't want to waste my time here. That's why it's like in a bit of rush now. So when you get time, go through them. Okay. I've explained what the fork does. The exec v creates a new like replaces the old program with a new one. Okay, so go through these two. After you are able to go through the exercise and everything, the codes you able to come by, please don't do away with them. From the ALS resources, teaching you the system inputs and everything. Okay, citizen. Please ask your question.
Okay, thank you so much, Mr. Solomon.
Hello?
Thank you so much, Mr. Solomon.
Please, you
I
said?
want to ask. Are you hearing me? I want to ask. Are you hearing me now?
Yeah, I can hear you.
Okay, is that can we change all those file names?
Found names. Which ones? Is it a program?
the
The commands?
yes, the program. Yes, yes. No, the program files. Can we change it?
Okay, okay, okay. Good. Thank you for the question. Is that all?
After that one first, just answer me.
Okay. Please no. Don't ever try that. Okay. When you don't try changing the program, when that was a good question though. So this is what you want to do. Okay. With the exec v, okay. No, what should I even use for an example to explain to a citizen? So so what we are doing is we are taking the user's input and we are handling it. We are using the shell as what? Um, this is what will happen. Okay, citizen, this is what is going to happen. When you want to change your file name, everyone knows what ls does. Everyone knows what ls does. Everyone knows that ls is what is used to list. Let me clear the screen. So let me go to cde. Let me go to the user. Okay. It's like it's a general something. No, yes. So it's a general something. Everyone knows these commands, these files. They are standard. So you changing it will affect how your shell is built. Because imagine changing ls to a name like lse. Okay, and your shell, someone else is using your shell elsewhere, and then they try to enter ls. Okay, and then your shell is does not know any command called ls because when you're implementing your shell, you try to use lse. Okay. So what it will do is that the shell is going to go through what the operating system and it's going to see if it will find any command called lse. It's going to find any file called lse. If it finds it, it will execute it and it will work just as it is. But please no, don't change these file names. There is a reason why they are in a binary. This yeah, on the normal terms, let me use something like my vagrant tool around. Let me use to explain why you can't change it. Because first of all, you're not even supposed to have access to it. If you're using things like vagrant and other, and you're not a root user, they don't let you get access to these files because they are very how do I say delicate. You don't want to mess with them. Don't go into them. Let me open one for you to see how it is. The reason why you don't want to manipulate or tamper with them is that let's see the V, the LS. Okay. So this is what it is. Okay. It is it is not it is an executed program. Okay, it's an executable program, so it has already been what compiled and everything has already been done. You don't understand these things yet, so you don't want make changes because when you make changes to this file, it affects how what the command works. Okay, so please no, you can, but don't change the names. Okay, don't change. I think everything's for you can do everything you want, but just don't change the name. Don't do anything with it. Just focus on what getting your shot. And first of all, ALS doesn't want you to even. You are not going to do with these files programs. Yours is just what shell, and I explained it earlier. Yours is what how the shell is going to ask what the operating system, how it's going to communicate with it. So these things, see, sorry, I always remember. I forget that CD is not part. These things are not your story about, okay, citizens. So don't be too much focused on these files. They are not your story about. Yours is what shell. Yours is this one. How it is going to react with what the operating system and what and the user. Okay, so that is where you stand. That is your main focus. Forget about the operating system and its files. It was just an explanation for you to grasp the context. So, is there think okay, Josh, let me have your question. Or if you want to add anything, if you want to answer our brother.
Okay, why I asked that question is that
Okay, okay, I'm listening.
why I asked that
Hey,
question is
Solomon.
that on
Josh, please wait for us. Please talk. Citizen talk fast. Let me
All
listen.
right.
Uh-huh.
Okay. Why I asked that question is that on our printf,
Mm-hmm.
we I changed some files name. So and thing goes and my all my checks all green. So that's why I asked the second question that is it possible we change files name again on this project?
Okay. Oh, okay. You mean in the project?
Yes, in the project,
Oh, in
yes.
the project, not in the operating system. Okay, in the project.
No.
Sorry, I didn't understand you well because you said program. So yes, the file is you decide how you name your files, how you want it to be. Just make sure that at the end of the day, your program is it's a program, okay? It is not a task. So at the end of the day, your program is doing what's required of it. So you can have a lot of files. When my partner and I started, we used one file. Okay, it was just one file. And as the code was getting complex, we decided to what that it was too chunked up. So we need to get some in other files to make it easy to read and easy to access. So it all depends on you. File names and everything. ALS is not going to give that to you. Okay. So you decide on all of these things. Okay. Does that make sense, citizen?
Yes.
Yes. So,
Thank you.
okay. So before that, you can name it according to what these steps have given you. You can name your files. Like let's say you have a file to handle a file that contains a function to handle user input. Okay, so you want to have another file that will pass the input, that is to interpret and differentiate between the arguments and commands using the string token. You'd want to have a different file that will handle the inbuilt functions. All depends on you. You are free to go with it. You can have as many files you want as long as your program does works just like what the normal shell. So Josh, please, what's up?
Oh yeah, I was just looking at on the collaboration part with the partner. How are we supposed to collaborate?
Okay, okay. Okay, so with collaboration,
Yeah.
ALS shared a resource on how you're going to be able to collaborate on your with your teammates and
One,
your partner. I'll find that and I'll
one,
share it with you. Okay, please talk. I'm listening.
okay, so one partner should have the repository, and then the other should um be a collaborator, right?
Yes, please.
Yeah. Yeah. Thanks.
Yes. So one
Okay,
thing you
that
want
was
to
my
know
thing.
is, Josh, are you okay?
Yeah.
Okay. So one thing you want to know is the contributions as Josh wanted to know. This is for those who are basically like new to it. Please, when you are done talking, can you please mute it? Let me answer Joyce. Citizen, do you have another question? Okay, good, thank you. So let me try to explain something. Okay, if you have a question, please wait for me to finish with the contributions. So ALS is expecting contributions, like let's say you and your partner are contributing equally. Okay, so then it's something like I'll share the resources with you to explain better. But one thing you need to know is communication. Okay, you need to communicate with your partner, and also you need to work hand in hand. Work hand in hand. And also, you need to separate the tasks, like share it among yourself. Don't share responsibilities, okay? It's easier when the two of you know how you are. Like, let's say, what are you doing? Like, let's say the steps I gave to you, you can say, oh, so partner A, you can let's start with how we are going to take the user input, okay? And then they start working on that. And then later, you also add how we are going to handle passing of the input, the arguments, and then you can just work and in sync like that. Don't be a burden onto your partner that you'll be so hard to access. Let's say I don't know, like how I was a burden to my partner. Like it becomes difficult when one person is like doing most of it because it becomes tedious. Simple shell is not simple when it's just one person doing it. Okay, so it's very easy when the two of you are bringing hands together and you are doing the same thing in sync. Don't be a burden onto your partner. Contributions also matter. So that those are some of the things I would say in the contributions. Yes. So let me move to design consideration, then I'll be done. Okay. Let me touch on design consideration. Design consideration basically has to do with how, sorry, my pad is a bit rough because I've been using it several times. So My handwriting is naturally bad. So what you want to do is you want to have the user input, okay? You want to handle user interface. This is how the show is going to look like, okay? How you're going to design it. The user interface, like what are you printing to the user? What is the user seeing? When you go through the ALX resources, it touches on all of these things. Is there a prompt notifying the user that yes, he can type now, he or she can type now? Are you communicating with the user? It's basically what the design consideration. You need to consider all of these things like the user interface. What is your short printing? After every command, what is it printing again? After every process, what is the feedback? When there is an error, when a file is not found, what does it return? Command not found. Consider these things. You need to consider passing input too. It's basically the same thing as the first. Yes, this I was saying was the trickiest part, like how the user is able to differentiate between how you're able to differentiate between arguments and commands from the user, and also you want to check. Okay, so for the design, you basically need these things for the handling of errors. Yeah, error handling. Are you printing the correct error to the screen? I hope your error is not confusing. Like let's say, supposing this, let me use this. Okay, this command not found thing I was talking about. Let me go back. Oh, this command not found thing. Let's say you enter something like, let me clear the screen. You enter something like this. So what is the user seeing? Command not found. Did you mean how do you handle errors in a situation where the user wanted to redirect something into a file and it just ends like this? How are you going to handle it? That is when signal handling also comes. Like let's say if the user just enters this and does this, how are you going to handle it? All these errors, you need to be able to come up with it. And it's very easy when you know the right functions and system calls to use. How let me separate the signal handling from the error handling. So add this one to it too. Search two on signal handling. Very important. I don't know, let me just bring it here then. It was number what? Number four. Yes, number four. Signal handling. Like in situations where the user enters control plus D, control plus C, what happens? How is the exit is actually control plus D. How is the your shaw able to interpret it? So you want to handle all of these signals. Okay, so yes, basically I've touched on most of the things I said we are going to touch on. These basic things you need to consider for now. And the next advice for me is that please try and what go through what ALS resources, what they've given you. And for the sake of time, our next meeting will be communicated to you. And also to ensure that you do this thing, this is what I'm going to do. I'm going to be expecting the next time we meet, I'm going to be expecting results. Okay. I'm going to be expecting results, what you've experienced so far from the ALS call resources, what you've been able to done so far, what the problems you're having. We go through them because believe me, that is the basics. If you're able to understand them and combine these things I've shared with you, it makes it very easy. Okay. So the next section, one thing we missed in our project was what the right system calls and the right functions to use. Okay, so the ones ALS provided for us, I want us to go through all of them one by one and how we are going to implement them in our course. Because during our time like this, stuff like interactive mode and non-interactive mode, there was just a simple command that could handle it, and then we're just wondering how does our show interact in um, non-interactive mode? How does it act in non-interactive mode and interactive mode? And then there was just a command that was, I think it was isati, right? Yes, it was isati. So if in case you didn't know that there was a function like this or the system call like this, you are just going to keep on wondering how you are going to implement that. But once you go through all the functions and know what each and every one of them does, you'll be able to implement all of these things, and it's very easy. So please, the next section, I'm not going to touch on the resources ALS has given us, like how to use the fork, exec v, wait, how to get your environment. I'm not going to touch on them. global environment variables and everything, I will assume that you've learned them from the resources and you're able to implement and build a basic what implementation of what the shell. Then I take it from there and we go straight with your codes or what you've written so far. So and then I'll also try to implement my basic shell that will work like yours, so that everything will be handling. You also be what implementing them in your what in your codes. Everything I'll be implementing in my basic codes, you'll be implementing them in your what in your codes, for it to be very simple for all of us. So this brings us an end to the meeting. I don't want us to exceed 2 hours. It's long because of YouTube. I'll be updating it there. So please, yes, basically that's almost everything we need to know for today. Any other questions? Any contributions? Anything before we end? Let me. Yes. Okay. So, is there anything anyone wants to share? Anything? Anyone wants to ask anything? Anyone confused? Is there something you want to know? Something